Okay, I'm going to show the ASCII data driver now. This isn't an add-in. You just browse directly to a .asc file, and it does require the .asc file. So it's not going to work if you have a text file or CSV file. It's got to be renamed to a .asc. And then you need to have a minimal header above the data, and that header starts with begin and end, as shown here. And the data can either be tab or comma delimited. So here's an example where we begin the header. It starts at 0 seconds. It's got a delta of 0.0008. The unit has been specified for 1, 2, 3, 4, 5, 6, 7, 8 channels. Channel name is specified for 8 channels. Looks like 4 of them are radial and 4 of them are axial. This is an option to put it in the channel group. But if you want to process it in Testlab Classic, you can provide the channel group as acoustic, vibration, other, or tacho. And that'll be imported. And the header ends with end, and then you have the data immediately following that with either tabs or comma delimited data. And then here's another example of a header where we can specify the start. Time can be specified as a delta, or the sample rate can be used as rate. So to specify the sample frequency, you can either use delta or rate, up to you. You can also set an absolute timestamp if you want. That would be EDA, absolute time, and then you would specify the date and time in this format. A y-axis unit label is specified as unit. Channel name is specified under channel name, and channel number would be under EDA channel ID. So this is the different syntax in the header we would have to use. Okay, so let's show a couple of examples of that. So here's some ASCII examples. So here's a 4-channel data that's comma delimited. So I go back to one of these front back, and I can just display it. So there's my accelerometer. It's in meters per second squared. There's inline, that's voltage. There's load, Newton, and then there's microphone, which is Pascal. I also have it, if I show those files here. So here's the ASCII examples. So this is 4-channel data example, comma. 4 data channel. So here I have the ASCII file, and I skip the header. So what people don't realize is I can actually create a .header file that has just the header in it. So here I have just the header. Then I could change this, and then I can have a file with exactly the same name with a .asc, and then I can give it new data sets. So this header could be copied multiple times with a slightly different name, then bring the data in the same file name format with a .asc instead of a .header. So these two need to go beside each other. So here's an example of the 2 files with tab instead of commas. So here's the same header, but now the data is tab delimited instead of comma delimited. And then here it was comma delimited. So if I look at the comma delimited, that's this file. If I look at the tab delimited, that's this file. And then if I wanted to bring it in with no header at all, I still can. You just don't have any point ID, and it's going to assume a sample frequency of 1. Okay, it's going to know its function class. So it does know that the function class is time, so I can immediately process it. But it's going to assume a sample frequency of 1. So if I go back to the slides here. So header is the same for the comma and tab delimited files. You can have the header inside the file between a begin and an end, or it can be a separate file with a .header name beside the data in the .asc name. If no header is used, it's still going to import the data. It's going to know its function class equals time so we can process it, but it's going to give it a sample frequency of 1 with a time increment of 1 second, and it's going to give it a y-axis of unitless or slash. And then we can always adjust the sample frequency and the point ID and the y-axis in Testlab if you wanted to, but it's going to bring it in exactly like this if you have no header specified. Okay. I had a couple of different example files as well. So here's an 8-channel example. Okay. Here's an 8-channel example with a channel group. So if I get the properties of this data, so here's the details, and here it brought the channel group as vibration. Here's some data with the iRig data. Here's an example. Here I can change this x-axis to be absolute time, and I can see the absolute time format here. And if I look at that in a text editor, that's this file here, and here this absolute time was specified with this absolute EDA absolute time field.